Hello, Performance Summit crowd. Thanks for having me. My name is Andreas Grabner. I'm broadcasting live from my kitchen here. Uh, Very happy that I can talk to you about performance engineering, about automating performance pattern detection in distributed architectures. I've been working in performance engineering for the last about 20 years. I started my career as a performance tester on a performance testing tool. I used to work for a company that built performance testing tools, and I was a tester, as I said. Then I switched over to helping people running performance tests, doing analysis. And for the last 13 years now, I'm more on the monitoring observability side, working for a vendor there that is providing observability. Now, lately in the last 2 years, I've been spending a lot of my time in the open source project Keptn, which is a CNCF sandbox project. And I'm also going to talk about this today because it's going to be part of my live demo, showing you how we can automate problem pattern detection in distributed architectures. So let's get started. Let me share my screen because I'm pretty sure you want to see actually the meet. So this is me. If you want to know more about me, or if you want to get in touch with me, Twitter handle is here, LinkedIn. Most importantly for me is also that you get to be aware of Keptn, the open source project. You can follow us on Twitter, star us on GitHub, and join us on Slack as well. Right? So let's get started. How do distributed systems look like, right? Or maybe how they shouldn't look like. Here's an example that I have taken from a presentation with one of our users. They are running their distributed architecture on AWS. It was a presentation we actually gave at the AWS Summit in Berlin, looking at a distributed trace. And the interesting thing about this is, and I'm just pointing this out here, this is not even an extremely complex application. I mean, it is already kind of distributed and complex, but we've seen even worse. But what you already see here, there's a lot of different components running on different types of technology. Some of those even running in AWS, in this case in the cloud, some running still on-premise, some are third-party services. So distributed systems can be quite complex and a lot of moving pieces that some of them you may control, some of them you may not control, or you rely on or you depend on. But then besides the dependencies in distributed system between services or service entities, we also have dependencies up and down the stack. So this is an example of a distributed app, as we can see the service and then where it runs on, right? It's distributed across different processes, across different hosts, maybe running in one or multiple data centers. So dependencies are very important. In the end, what's very important is, as we are designing these systems, as we are building services that are kind of built into a larger application, we always need to understand what are the dependencies, who is depending on us and who are we depending on. Because if, let's say, the journey service, if this is your service, then those that are showing up here in that trace, or we call it the service level backtrace here, like who is calling me, then they are depending on me, and I might be depending on some other service that I'm calling down the line. So it's very important to understand who are you impacting in case you change your behavior. And I want to get started with actually talking about a lot of these patterns that I've seen in distributed architectures. And I've been doing this, as I said, for about 20 years. I've helped people run tests, but then also analyze tests and analyze distributed traces. And I've seen a lot of very basic common patterns. Now, I'm not going to show you how, to do maybe CPU optimization tricks on like to get a little nuance out here. These are very common basic patterns that many of you may know. But what I want to achieve with my talk now is highlight that I see these patterns all the time, and we need to make it easy for everyone, also those that are not performance experts and not performance engineers like you that do this on a day-to-day basis, how we can give them something to avoid these problems ending up in a production system where they probably have or potentially have a very negative impact. So there's many patterns that I could talk about, but I'm just focusing on a small number. If you want to know more, I have done other presentations where I cover more of these topics, whether it was on some of the meetups that I did, some other conferences. The links are here, and we'll share the slides so you can also find them later in case you don't get a chance right now to follow up on those. The number one classic is the N+1 call pattern, or more 1 plus N. I think for most of you, very familiar. I see a lot of organizations that have their monolithic apps. that may look like this: a function get total quote with a for loop where they're looping over a list of products and then, let's say, calculating the sum of the quotes. Works really well in a single process, but then a lot of organizations are now trying to figure out how to decompose their monolith and put them into services. So one of the things could be, how can we get the product here into a service? And this is actually one thing that one of our users has done. So they had the quote service and then product services. So they ripped apart this piece and just used the same logic, meaning that same loop, which meant that when you have one call to the quote service in the front, you end up with a lot of calls to the new product service now, because every loop is making a call to that no longer local function call in the same process, but to now microservices that might run distributed across different cloud providers, different Kubernetes clusters. So that's already a problem, because you have a lot of chatter going back and forth. For every call, you get n calls to the backend. And this is also why it's called the N+1 or the 1+n query pattern. And you can see that this is obviously not scaling, because the more products you have in your quote, the more calls you have. Another example, a case study that we did with LandBay, same thing, but even more dramatic in terms of the numbers. One call that came in the front was then going into making 74 calls to a database, 24 going into a queue that was then picked up by some listeners that then kind of forwarded the whole these messages into more and more different systems in the back. This is just a subtotal of their end-to-end flow, but you can see a single message is basically sprawling out to a lot of different services, and it's multiplying itself. And this, in some cases, might be intended, but in many cases, it is not intended. And this is why it's important that we always have an eye on what happens with a message that I send or with a message that I receive. How do I impact people around me? Right? Do I make these calls the right way, or are there better ways to achieve the same result? Maybe instead of making 24 calls to the backend system, talk with that next system, try to figure out if they can provide a better API so that in batch you can receive the next items, right? The next 20 items, the next 50 items, instead of going back and forth all the time. So the N+1 call pattern, I also like to just extend it to the N+1 query pattern. So here, same example as before. Remember the quote service, the product service. So one call comes in the front. In this particular example, we ended up having 87 calls to the database, because every time the product service was called, stateless, the product service first had to get to the database, authenticate, make sure that everything is good, that you are, so the authorization also happened there. And then query that piece of data that was actually required or that was requested. So leading to a lot of calls to the database. Right? Remember, starting from a very simple looking piece of code, a loop that was just summing up quotes of products in a catalog or in an I think it was an insurance claim or something like that. So now this can go even further. Here's another thing, another organization I worked with, building it's a Java application going to a Postgres database, nice cascading effect of a single query on the front end resulted in, as you can see here, 26,000 database calls. And this is obviously not efficient, right? But the thing is, if you don't know about this, if you never look at, even in your test environment, hey, when I may be executing my search and I have, let's say, 50 items in my database, does my code make 50 individual calls to the database? Then this should already be kind of alarming to me, because it probably tells me that if the database grows with more entries in production, I will probably see the same pattern, and then I'll get a lot of database calls. Last kind of pattern that I want to talk about, inefficient service flows. This is where I draw parallels to the web performance optimization world. I had a couple of years ago, I was active in web performance optimization, working with people like Steve Souders, John Resick, and others to really analyze page loads of web performance. Like, how does your page render? And I see very similarities now with the distributed architectures. So what I really like to look at when I analyze why does a certain request take so long, I look at what we call the service graph here. you can get this from your distributed tracing system. And what I've seen is that a lot of people think, hey, this is the architecture that they have. And then they make changes and never kind of look back at the end-to-end trace. And often then you end up with things like this, right? Where you make a single configuration change, where you're adding things to it. You're including a new third-party service, you're changing a library, and all of a sudden these libraries go off and do new things. So what I keep seeing in these worlds is we're loading, again, we're involving a lot of services that all connect again and load other resources and services. And then if you look at this view here, this kind of reminds me, as I said, to my times when I did web performance optimization, the waterfall graph. It's a waterfall graph of what gets loaded when and how long does it take to load the initial request completely. And what is bad about this is, well, this is bad because a lot of resources, it takes a long time. But what's bad is that we don't look at these things on a continuous basis, because otherwise we should never see these things in production. But this was something that we saw in production. This is why this is not good. So as you can see, these are very simple patterns, but I see them all the time. And I've been trying to educate engineers over the last 15, 20 years to look out for these patterns. And it seems I haven't done a good enough job, because otherwise I wouldn't see these patterns all the time. Now, what I think I can do though, I can keep educating. This is why, right? This is kind of my list of 8 patterns, and also next to it, metrics, because I'm a big believer that most of these patterns can easily be detected by looking at metrics that you can extract from your logging, from your monitoring, from your observability tools, like the N+1 call pattern. I can get an easy metric that tells me, for one incoming call to my service, how many calls do I make to the next service that are completely the same, right? Like the product quote example, or the N+1 query problem. One call comes into my service, how many database calls do I make to the database, and how many of them are completely the same, like in a loop I'm making calls. Others, there's a couple of things that I didn't walk through in detail, but you can see for every pattern, you can define a metric that tells you, do you have this pattern in your application, yes or no? And the thing is, if we have metrics, then yes, we can also automate the detection. And the way I would start, right, is by actually thinking about integrating this into your continuous delivery. Now, whatever continuous delivery tool you have, I believe that what you should do is, first of all, take your observability tool, your log analytics tool, try to find the patterns, try to find the metrics, and then put them on a dashboard. But just putting them on a dashboard doesn't make you stronger, doesn't automate the whole thing, and also doesn't give this capability to all of your developers. This is why you have to start with the dashboard and the metrics, but then instead of manually looking at this dashboard after every build and educating more and more developers to look at the same dashboards, I want to give you the solution, which in my case is the open source project Keptn. So this is exactly one of the use cases we built into that open source project. Keptn can be integrated in your CI/CD tools. Keptn can not only execute your tests for you, like trigger your testing tool of choice, but it then also reaches out to your log analytics tools, your observability, your monitoring tools, basically looks at those dashboards for you, looks at the metrics, and automatically grades every metric based on a threshold that you can specify, or by looking at how did the behavior change, how did the metric change to the previous build. So for instance, did the number of database calls increase from the last code change to this code change? If so, strange, because we have the same functionality, the same tests, but all of a sudden the number of database calls goes up. So maybe we have made changes that is now changing the behavior, and we want to be made aware of. The beauty of this is this can happen fully automatically, right? So and instead of spending many minutes to analyze these dashboards, we can fully automate this, and with this also give this to more engineers. So this is why, let me quickly introduce you to Keptn. Keptn can do more things than just what I'm going to demo later on. You can pick your use case, quality gates, delivery, SRE automation, auto remediation. The nice thing is it's declarative, so you bring your configuration depending on the use case, like we will see later on. your workload to execute tests and your SLIs and SLOs. Then you connect your tools. You can bring the tools that you want. Keptn is an orchestrator and is not actually executing the load on its own or doing the analysis. It is reaching out to these tools that you have. What it does, it automates the configuration of all these tools. It connects them through a workflow that you can specify and provides them these use cases as a self-service for you. Everything is declarative. All the configuration files are stored in Git. Everything is SLI and SLO based, and everything is based on standards, meaning all these tools that you can integrate with Keptn are based on cloud events, which is an open standard, which means do me a favor, if you like what you see, but you don't see your testing tool or monitoring tool or SRE automation tool on here yet, you can easily build an integration, and it's based on an open standard. From 10,000 feet, when you install Keptn, Keptn itself needs to run on Kubernetes. You get the control plane. Keptn is an event-driven system. In order to use it, you can specify your processes that you want Keptn to automate. Once our processes around continuous delivery and test automation and quality gates, that's where we specify so-called shipyard file. You will see this later. The other use cases that Keptn can also do is around auto remediation. It's around bringing systems back to a healthy state in case they are, troubled by some strange event, let's say in production or even in chaos engineering. Then this is the nice separation of concerns. On the one side, you specify the process. On the other one, you specify the tooling. So you can plug in any type of tool and at any time change tooling without having to change your processes. That's also nice. We call this the execution plan, or we call it the uniform of the Keptn, like which tools, which capabilities do you plug in? And in the end, the beneficiary is, let's say, the developer that can say, I have a new artifact, now please execute that delivery workflow or that test workflow or that evaluation workflow. And then Keptn will execute that workflow by sending events like, hey, deploy, run the tests, evaluate, and then triggering the individual tools in your case that can actually then do that job. All right, so now let me show you a demo that I've prepared. I told you I'm a big fan of dashboards. So start with dashboards because this is typically what we build as performance engineers, put the metrics on it that are important. You can then augment the dashboard with what you would normally look for, like what are your thresholds that you would normally look for. Now, an additional thing that Keptn can do, it can also execute tests for you. So in this case, I'm also providing my JMeter. I'm using JMeter as an example, and then Keptn fully automates the test analysis and the test execution. And then for me, it comes back with either everything is green or everything is red. So let me show you. Let's switch over. Yeah, where do you get started? So keptn.sh, you'll find more information here. You can also get to the GitHub repo. You'll find more information on the community and so on. The application that I have used or that I'm using today is a multi-tier, multi-services application. We call it Easy Travel. In my case, it is deployed on a GCP cluster. It's actually a containerized app. Easy Travel, you can do certain things, right? You're clicking special offers and stuff like that. But that's, I think, not the point of how complex the application is or not complex. I've instrumented the application with Dynatrace. So that means Dynatrace in this case is monitoring. If you have your own tool, if you have Prometheus metrics, if you have any other monitoring or data source, remember, Keptn is agnostic to the monitoring tool. You can build the integration for yourself. I'm using Dynatrace because that's where my day job is. But you can see here, fully instrumented, and we have metrics later on that show us how many calls come in and how many go to the other different environments. I also have a Keptn setup. So I've installed Keptn on, in this case, it's a EKS cluster in AWS, where I have 3 projects. I also have Hipster Store, but today we want to focus on Easy Travel. Most importantly here, you can see there's a GitHub repo. So Keptn internally holds everything in a Git repo, and I've specified an upstream to my GitHub project here. So initially, in order to set up Keptn for performance test automation and analysis, remember I talked about the shipyard file. So this is it. I basically say I have a performance stage, and the test strategy by default should also be performance, right? Sounds easy. Really, that's what it is. Once you create a new project with this shipyard file, it automatically creates a branch for every stage. In my case, I have the performance stage. In here, I can have different services. Mine is called eval service, so for evaluation. And in here, I have my supporting files that Keptn will need and passes on to the different tools that participate. For instance, under JMeter, I have my JMeter load file, my data files. I also have a config file where I can, for JMeter, specify different test strategies. So I can actually tell Keptn, hey, the default test strategy is performance. But if I may ask you, then instead of executing the regular performance workload, just execute a different workload for me. So this is where you define the workloads. Then what I also have in here is SLIs and SLOs. This is where you can specify how do you want these metrics that then Keptn will pull out from a monitoring tool be evaluated against the thresholds. So this is the repo. And now, if I want to kick it off, if I want to say, Keptn, I now want you to execute a test against this particular application that I have set up for you. The only thing you need to do is you need to send in a request, right? Keptn is API driven or event driven. So in order to kick off a workflow, either from, let's say, your CI tool that you have that did the deployment, or maybe through, we also have a CLI, you basically send in an event. And in order to kick off a performance test event, you say, hey, Keptn, I just finished the deployment. Here is the URL where my deployment can be found. And I now want you to launch that process in the Keptn project Easy Travel in the stage performance for the service eval service. So this is where Keptn then sends events and say, hey, I now need somebody to test. And it will be picked up by JMeter in my case. The JMeter tests will be executed based on the test strategy. We'll look at the workload, run it, and so on. And at the end, it will then analyze the data from my monitoring tool. Now, there's a long list of metrics here. Remember, I talked about all of these different metrics to detect my problem patterns. So what I've done, I have two options. I can either specify so-called SLIs or SLOs, or I can just build a dashboard and I put all my dashboards on and my metrics on, and like things like number of database calls are here, JVM health metrics. I have metrics for each individual test transaction that my test is executing. So I put it on here, but instead of me looking at it, Keptn automatically looks at all these metrics, analyzes it, grades it, and then comes up with a total score. And this is then what allows me to immediately check, do I have any problems, yes or no? So there's definitely much more I could talk about, but I know we're considering the time. I hope we also have some time for Q&A. I want to wrap it up. What you should have learned today is that there's a lot of patterns out there. And I think most of the patterns I've shown you, you have also in your application that are struggling, where you might be struggling, but there might be more. So understand your patterns and then define the metrics that tell you about those patterns. Then try to monitor those metrics, put them on a dashboard, and then let Keptn automate the analysis and also the test execution if you want to. And integrate this with whatever delivery tools and operation tools you have. Now, if you want to learn more, I was recently also invited by Tarash for giving a talk on Keptn itself as part of his Scaling Continuous Delivery conference. Check it out, it's on YouTube. If you want to check out Keptn, keptn.sh, join our Slack channel, and so on and so forth. And with this, I want to say thank you. Hopefully this helps us all to build better performing applications. I know I'm not telling you as a performance expert something new, but I think this is a framework that allows us to get more performance awareness into the hands of developers, because we can automate the basic detection of the top performance patterns that I've seen in distributed systems. With it, thank you and talk to you soon. Bye-bye.
Thank you, Andy, for the great talk. I don't know if you've seen, we have a question from the audience. So Ganesh Joe was asking if you have any thoughts about predictive analytics for identifying performance pitfalls in advance.
Yeah, I mean, that's obviously a topic that we are trying to address also on the production side. So as I said, right, during the day, I work for Dynatrace, where we have an observability platform. And here we're looking at production data, we're looking at patterns as well, and we are trying to get better with predictions based on workloads, based on patterns. But this is something I think we do right now at least, focusing more on the production side. I think that, however, and maybe this is where the question goes to, we can learn a lot from production. And the question is, how can we kind of take what we learned there and bring it into our delivery pipeline? So for instance, one drawback of the approach that I showed here is I said, build a dashboard and then you put in your metrics and your thresholds, which is kind of strange because why do I need to specify thresholds if I already have an app that runs in production? So shouldn't the threshold be, or my baseline be, what's running in production? This is also what we're doing now, is we're extracting production baseline data and then using this when we compare our metrics as part of delivery. The other thing what we do is, a lot of monitoring tool in production, they do a good job about detecting problems and also the root causes. The one thing we're working on right now is, let's say, looking at all the problems that, let's say, happened in the last 30 days, cluster them together and say, okay, what are the most common problems and what are the root causes? Is the root cause something that is related to a configuration or code change, something that we can pinpoint on a metric? And then instead of me as a performance engineer having to figure out which metrics I want to look at, I just say, let's take the stuff that we know from production and let's push it back and include these metrics that have caused, let's say, 80% of the problems in the last month. So these are some of the things that we're working on. From a prediction perspective, again, to answer that question, it is something that I think most vendors are in the observability space and also open source tools are trying to address by just looking at trends, at models, and then making predictions on, hey, when are you running out of your capacity? When are you, with this code change, when do you think you will probably run into some limitations? Something that we are currently not addressing with the Keptn open source project, but it's also not our target use case.
Thank you. And I noticed that when you're opening the presentation, you're highlighting how some engineers, they are chasing the shiny objects of optimizing CPUs or solving the hard problems. And it sounded like you're mentioning these 8 patterns that people keep repeating, 8 non-performant patterns people keep repeating. It seems like there's lots of low-hanging fruit that we could find easily.
Exactly, and this is why I'm really sad that after 20 years of being in that space and really trying to educate folks about these things, and that I still see them with every application that I analyze. I can tell you, I find the same problem patterns. It's a funny fact. So that a couple of years ago, I've been working for Dynatrace for the last 13 years, and about 10 years ago, I had a program where I allowed our users to send me their Dynatrace data, and I analyzed it for them. It was called Share Your Pure Path. So the Pure Path is our distributed trace. And then I had my own prescriptive model. I knew when I look at the Pure Path, I click here and here and here. And then I know, do I have this pattern, or this pattern? And then what I did, I sent back a PowerPoint presentation, basically with screenshots, and say, look at this. It took me 3 clicks and I have these patterns. And then what we did, we built this into the product. We called it Andy in a box. I mean, that was kind of the internal nickname. Because basically what our engineers did, they said, because I really ended up having 200 different PowerPoint presentations with screenshots of how I navigate through the product and how I always detected the same patterns. So we just automated that and put that into the product. And then we had a screen that says, here are your 5 problem patterns that we detected on this app or on this distributed trace. And yeah, but even after 20 years, I still see the same patterns, and a lot of them are low-hanging fruit. Not all of them, but a lot of them.
Yeah, it's impressive. And I think really the only way to scale up from product engineers to product engineers is to really make it super easy for product engineers to understand, oh, here's what I'm doing wrong, and here's the few changes I have to make so that my code runs faster. Yeah, we need to scale ourselves up as well. We can't be everywhere.
Exactly. Yeah.